Hello everyone and welcome to our second video in the quadratic functions unit. Today we're going to look at the factored form of a quadratic function. Factored form is simply another arrangement we can write a quadratic function in. Factored form looks like this. Y equals a bracket x minus r bracket x minus s. A is a number and it's the value that determines the width and direction of the opening of the parabola. The r and s are the values of the x-intercepts of this parabola. All right, the first example. Determine the quadratic function that defines this parabola. Write the function in standard form. Now you might be wondering, why are we talking standard form when you thought we were talking factored form? Well, if I'm trying to write the equation of a quadratic of this parabola, I can't go from the picture straight to standard form. I need a different arrangement, an easier arrangement to work with, to start off with, and then once I have that, then I can transform that into standard form. So what I mean is, I'm still going to want to use my factored form. Once I get my factored form equation written out, I can then transform it into standard form. I can't go from the picture straight to standard form. I need a middle step. All right, so with standard form, with factored form, remember we want values in these three positions, in the A, the R, and the S. So the first thing I'm going to find is the x-intercept. It doesn't matter what you're trying to do, but I want my R and my S values. So you can see here, those are my x-intercepts. So I'll say R is equal to -3, S is equal to 1. It doesn't matter. I could have reversed them. That doesn't matter, so don't worry about it. Now, so I'll have R and S taken care of. I then need to figure out the value of A. So in order to do that, I can't look at the graph to determine the value of A. I need to solve for A. So what I'm going to do then, or now, is I need to find a point on the parabola and take the x and y values from there, and then I can place them where I've put the green arrows. That would mean the A is the only variable left over, and I can solve for it. So you can choose any point on the parabola. A nice easy point that I'm seeing stand out here is my vertex. So I need a point. My vertex is -1 and 8. All right, so now I have all the information I need. I can rewrite them here really quickly just so we're on the same page. R, S, X, Y. R we said is -3. S is 1. My X will be -1 from, that's the X coordinate from my vertex, and the Y will be the 8 from the vertex. Now, why am I doing this again? Because I need to find the A value, and to find the A value, I actually have to solve for it. So now I'm just going to plug in these values. So instead of Y, I write A I'm stuck with. X now becomes -1 minus my R value, which happens to be -3. So maybe I'll bump these up to square brackets so they stand out. X, again, is -1 minus my S value, which happens to be a +1. So now you can see I have numbers all over the place except for the A, and now I can just take my time and solve for A. So 8 equals A, this is plus, so -1 plus 3 is 2. -1 minus 1 is a -2. So I have 8 equals -4A. Divide by -4, divide by -4. A equals -2. I now have the three variables that I need, the X, R, and A. So my third step would be actually, I guess this could be my third step, which would solve for A. My fourth step will be factored form. So now I have Y equals my A value, which is -2. X minus -3, that's my R value. So again, I might as well bump those up. And then X minus my S value, which is 1. Now I'll go through and clean up my brackets. -2, this ends up being a plus, so X plus 3, X minus 1. So that is this parabola in factored form. but the question asked for standard form. And the nice thing is you can go back and forth between standard and factored form by, well, in this case, I'm going to multiply to put it into standard form. And if something's in standard form, I can factor to take it into factored form. Now, sometimes there's more to the factoring, but in general, we can do that. So I'll start off by writing this thing out in factored form again. And then I'm just going to take my time and multiply. So however you want to do it, I'll do the brackets first. So I'm going to get x squared minus x plus 3x minus 3. And again, I'm just taking my time and going through it here. So x squared plus 2x minus 3. And then now I'm going to distribute my negative 2 in there. So negative 2x squared, negative 4x plus 6. All right, and that would be my final answer because the question asked for it in standard form. All right, so all in all, not too bad. Again, I cannot go straight from my parabola to standard form. I need a middle ground, a middle equation. So that's where factored form comes in. For factored form, if you have the picture, you can find the intercept right away, but you always have to solve for that a value. And you need any point from the parabola to help you solve. Vertex is always a nice point, but any point will do. This was some extra. All right, example 2. So same type of question here. New parabola. So again, I want to write this thing in standard form. I can't go directly from a parabola to standard form. So I know I'm going to be working with my factored form. So I'll make my little list. Remember, A, R, and S are the values you want to fill in if you're just completing factored form. We can find the intercepts from looking at the parabola, but I can't determine the A value. I'll need to solve for that. So that's why I need the X and Y value. So I need my X intercepts. My X intercepts. Here is one of them, so negative 2, 0. Let's see, here's another one, that would be positive 3, 0. So, sorry, R can be negative 2, S can be 3. That is interchangeable. I could have made R 3 and S negative 2. Again, we got to solve for the A value, meaning I need a point. So I can use the X and Y values from that point to solve for A. I always look at the vertex, but this vertex here, you can see that it's not a nice whole number, so I'm going to avoid it. I'm going to put it off like this as a nice whole number. So I'll use this point, negative 1 and negative 4. So the X now is negative 1, the Y is negative 4. Now I can solve for it. So let's go through and start putting everything in. Negative 4 equals A. Sometimes I like to kind of fill this out with empty brackets. Oh, I wrote X there. Which would be negative 1. And so typically I do this with my empty brackets. Sorry, everybody. So that would be negative 1 as well. My R value is negative 2. My S value is 3. You don't have to do that if you don't wish. Sometimes I think that helps people. Negative 4 equals A. I have a sign change here. So negative 1 plus 2 is positive 1. Over here, negative 1 minus 3 would be negative 4. So negative 4 equals negative 4A. Divide by negative 4, divide by negative 4. A equals positive 1. And now that's a positive 1, meaning my parabola should be smiling, and it is, so I know that's right. And again, this is step 3, and this is solving for A. Step 4 would be just writing it in factored form. So factored. So here's my general form, A, X minus R, X minus S. And again, I just want to fill in these 3 values when I'm filling in factored form. So I have Y equals 1 bracket X minus a negative 2. Make that square so it stands out. This one, X minus, what's my S value again? Positive 3. Now I'll go through and just clean up my brackets. Y equals 1, X plus 2, X minus 3. Okay, so that is my factored form. Again, why do I need factored form? Because I can't go from the parabola straight to standard form. So now that I have that, I can actually go into standard form. So standard. And not every question will tell you to write it in a standard form, but this is a nice use of factored. Like, why would you use factored? Because factored is really, it's an easy arrangement to use if you want to just write down the equation. If you see the parabola, I mean, you can find the intercept right away, so it's pretty easy to come up with the equation. Anyway, again, make sure you just multiply. So my a value is 1, meaning I don't need to write it down. So I'm just going to multiply this out. X squared minus 3x plus 2x minus 6. Y equals x squared, so that's a minus 3x, right? It is, and there we go. There it is in standard form. Okay? Extra room, don't need that. All right, well, so we're going to look at one more of this type. You might be thinking, I get it already, Mr. Troy, I don't need more help. But this one has a little bit of a wrinkle to it, so that's why I thought I'd include it. So again, I have a parabola. I want to write the equation for it. So I need to use an arrangement that's easy to work with. That's where this comes in. And we're going to show you a third arrangement on the next lesson, which is called vertex form. You can also use it in this case, but I like factored form. Anyway, so again, here's my list. So my intercepts, x-intercept. Now, if you look, you only have one x-intercept. It's negative 2 and 0. So if that's the case, in the R and the S, we just simply put the same value down. Second part, I need the point because I have to solve for A. You can't use the same point twice. So I can't use the point from the, you can't use my x-intercept as my point. So I'm trying to say, sorry, I kind of said that a long way. I use a lot of words to say that. Point. There's one that I see, 0 and positive 6. So this will be 0, this is 6. And now I can solve for A. So 6 equals A. Here's my empty brackets I was trying to talk about last example. All right, X is 0, R is negative 2, and S is also negative 2. So this is a plus, so 0 plus 2 is 2. This is a plus, 0 plus 2 is 2. 6 equals 4A. Divide by 4, divide by 4. A equals 3 over 2, so there you go. Just so you know, you definitely can have fractions or weird values as your A value. So again, that was step 3. That was solving. Step 4 is actually just writing it out in factored form. So y equals 3 over 2, x minus something, and then x minus something. That's my r and my s, which are both negative 2, so I have a sign change there, you can see. So y equals 3 over 2, x plus 2. And you could either write it as squared or simply write it out again, x plus 2, whatever you want to do there. Step 5, standard form. So this one, there'll be, I guess, a little bit more work just because I have to distribute that fraction in at some point. Not a big deal, really, people. You could treat it as 1.5 if you wish as well. But anyway, we'll do it. Let's treat it as 1.5. That'll maybe speed us up a little bit. And you're absolutely allowed to have decimals. So it's kind of whatever you prefer to work with. So that would be x squared plus 4x plus 4. I gathered my terms in my head there. Now I'll keep going. So this is going to be 1.5 x squared plus 6x plus 6. Now box that up, and there's my answer. So excuse me. So hopefully that makes sense now. If you have a parabola, you can write the equation in factored form. Then once you have factored form, if you wish, you can put it in standard form. I shouldn't say wish. If you're asked, you can put it into standard form. There's my extra space. I don't need that. Here are some steps, so feel free to pause the video if you want to write those down. Example 4. Now let's determine the intercepts, the vertex, axis symmetry. So I'm determining properties. So let's look at that. So let's start off with the intercepts. So I guess I'll say x-intercept first. For the x-intercepts, in factor form. So my r value is going to be actually negative 2, my s value is going to be positive 4. Now, y, remember, and you can actually remember this from the last example, that is how it would actually look in the so I'd have y equals 2 bracket this, and then this would be like that as well. So so the x minus is the default sign in the equation. So if it looks like it's a plus, it should be a negative 2 value. If it looks like it's a negative 4, it means it must be actually a positive 4 value. So those are my x. Sorry for the extra squiggles on the page. I can't really erase them because the only eraser function on this little program I'm using erases the whole screen. So we're going to have to kind of work with that. Now my y-intercept. Okay, to find the y-intercept, simply plug in x equals 0 and solve. So I have y equals 0 plus 2 and 0 minus 4. So y equals 2 times a negative 4, which is negative 8. You could also write that as a point. I could have wrote my x-intercept in point as well. However you wish to do it, your teacher might tell you they like it a certain way. Okay, so we've got the intercepts done. Now the vertex. So there's a little bit of work to find the vertex in the factored form. It's not crazy, but it's not as easy as the next form you'll be seeing in the following video. Here, 3, the vertex. Okay, so we have to remember that the vertex is located halfway between the intercepts, the x-intercepts, okay? So because of that, to find your, I guess you could say your p-value, that's the x-coordinate of your vertex, you simply add your intercepts and divide by 2. So my r value is negative 2, plus my s value, which is 4, divide that by 2. 2 over 2 equals 1. So I know that the vertex, the x-coordinate of the vertex is 1. To find the q, if there's no formula, you simply just plug in the x value of 1 into your given equation. So I guess I could just write q equals x plus 2, x minus 4, which is now going to be 1 plus 2, 1 minus 4. So that's going to be 3 and negative 3, which works out to negative 9. So the vertex coordinates are going to be 1 and negative 9. So again, the way we do that is to find the x coordinates. It's always halfway between your intercepts. So you just add your intercepts, divide by 2. And then to find the corresponding y that goes with that x, you simply plug that x value into your given equation, and it'll spit out your y value. All right, so there's the vertex. Axis of symmetry. Hopefully you remember that. Remember that it is always a vertical line. It is always equal to the p-value of your vertex. So x is equal to positive 1. That one's done. That's pretty easy. The max min value, that is also not so bad because that is based on your vertex. So max min. Okay, so it's nice to have a sketch of what's kind of going on here. My a value is 1 in this question, meaning I have a smiling parabola. The a is positive, so you're happy. It's smiling, meaning your vertex must be at the bottom, which results in a minimum y value. There is a lowest y value. So we have a min value, and that minimum value is whatever the y coordinate of your vertex is. So y equals negative 9. But again, you need to know you need to know whether the parabola is opening up or down. Concavity and width. All right, so that's based on your a value. I think we'll have to look at, we need another slide here. So there we go, yep. So concavity and width, I kind of lost my numbering. 1, 2, 3, 4, 5, I think this is 6. Sorry if my numbers are off, but whatever. Now concavity, what that means is just the opening up or down. And we already talked about it because positive 1, we know that it opens up, okay? Because it is smiling. The seventh thing is the width. Okay, and I'm not sure if we discussed this before, so I should tell you some stuff here. The width has to do with the a value again. So if a is equal to 1, or the absolute value of a is equal to 1, absolute value is just the positive version of the number. So if that's the case, we say if the absolute value of a is larger than 1, it is narrow. And if the absolute value of the a is less than 1, it is wide. So based on this, in our question, a was equal to 1, and the absolute value of 1, by the way, is just 1. So again, the absolute value is really just the distance a number is from 0. So 1 is 1 unit away from 0, so the answer is 1, and that means it is a normal width. So hopefully that doesn't seem like too much, part 7 there. It's pretty straightforward, really, and hopefully this next one maybe will make a bit more sense. So let's do one more. For B, same thing. We start the whole thing over again. So I need the x-intercept first of all. Okay, and I can see that it's going to be negative 3 and negative 6. Again, remember, if I wrote this in its perfect fraction form with the negatives, like x minus, like we're supposed to have, x minus, then that would mean this has to be negative 3. That would change it to a positive 3, which is what it looks like. This has to be negative 6, because that would cause the sign change, which would make it look like the positive 6. So those are my x-intercepts. Remember the y-intercept? There's no magic here. Just plug in x equals 0. Finding the y-intercept is never difficult, because when you plug 0 in for x, it just kind of wipes out a lot of stuff there. So negative 2, that's 3, this is 6. So 18 minus 36. So there's my answers here. There's my answer there. Vertex. Again, a little bit of work with this one. To find your p-value, you add up your intercepts and you divide by 2 your x-intercepts to be more accurate. So negative 3 plus a negative 6 divided by 2, which works out to negative 9 divided by 2. So negative 4.5 if you want to write it like that. And that's fine. Vertexes aren't always, or vertices, they're not always whole numbers. The q, the y part, is simply equal to, you write your equation down that you're given, and you just plug in your x value. So it's the same technique as finding my y-intercept. Instead of always plugging x equals 0 in, I plug in whatever my vertex coordinate is. So that is negative 4.5 plus 3 and negative 4.5 plus 6. Okay, so just going through, doing this. Sorry, my pen kind of quit working there for a second. That's 7.5, so my vertex is negative 4.5 and 7.5. So hopefully you can keep that straight. Again, that's not too bad, I hope. Let's look at the fourth part. So the fourth part would be, we've done both intercepts, the vertex, the axis of symmetry, I forgot. And again, the axis of symmetry is that vertical line that passes through the vertex. It's always x equals is the equation for every vertical line, and it's always x equal to the x coordinate of your vertex. That's your p-value, so negative 4.5. Fifth one, max or min. Again, that is based on your a value. So in this one, a is equal to negative 2. That means it is frowning. And so your vertex would be at the top. So I'm going to have a maximum value for this. And it's going to be y equals whatever your y coordinate is in your vertex, which is 7.5. Okay, so that's max min. Concavity and width. So concavity. Again, that is just the opening. The A value is -2. This negative means it's going to be frowning. So this is the concave down. If you just wrote down, that'd be fine. I know what you're talking about. And the seventh thing, the width. Okay, so we have to take the absolute value of our number. So we know A is equal to -2. So let's take the absolute value of -2. That is +2. So the absolute value is always the positive version of the number. Now, sometimes that might feel confusing, but hopefully it's not too bad. The absolute value of a +3 is still +3. The absolute value of -3 is 3. Again, it's really the distance from 0. So 3 is 3 units away from 0, and -3 is 3 units away from 0. We're just not worrying about direction. Again, because in distance we don't have negative measurements. But anyway, back to here, we're actually talking about this stuff. So based on that, I have a +2 that is larger than 1. So because it's larger than 1, we know we're going to have a narrow graph. All right, and that is everything there. Here are the steps. I won't read that out for you. You can stop the video and check that out yourself. Write it out, whatever you need to do. This is example 4, but that should really be example 5. Sorry about that, everybody. Example 5. So now we're going to sketch the graph of the quadratic function. So this is the final example. I know it's 20 minutes in or so, so it's getting kind of long. Yeah, so to sketch a graph, we need points. So the least amount of points we need is 3, so anywhere from 3 to 5 points. You're going to always have an odd number. Why? Because say with 3 points, I could get 2 points on the side and 1 vertex, so that'd give me the general shape. But building from the vertex out, if you got 5, you're gonna get more shape. So you get a better read on how wide it gets and all those things. So anywhere from 3 to 5 points is good. So what kind of points are we looking at? Well, if you find the x-intercepts and then your vertex, that's 3. You can then find your y-intercept and its point of reflection. That would be the 5. So 5 is better than 3, so maybe we'll work with the 5. So again, the first thing we'll look for is the vertex, or sorry, is these x-intercepts. This is presented in standard form, you can see, which does not tell me the x-intercepts very easily. We could solve for them. So what we can do is if we can just write this in factored form, then that'd be easy, right? So the way we convert this to factored form is simply by factoring. So I want to put this in factored form. Okay. F of x equals x squared minus 2x minus 8. So I'm going to be looking for factors of -8 that adds a -2. Let you think about that. -4 +2. So now I have my factored form. So now I can actually determine my x-intercepts. So I'd have +4 and 0 and -2 and 0. Again, always opposite of what it looks like in those brackets. We've talked about that a couple times. So now I have 2 of the points. Y-intercept minus, yeah. I guess sorry, I'm kind of arguing with myself. I can find the y-intercept now or the vertex. I'll find the vertex upon further thought. It doesn't matter, but if anyone's wanting to stop at 3 points, then that would be, you need your vertex. So the p-value is equal to r plus s divided by 2. So 4 plus a -2 divided by 2. So my sign change there, that's really going to be 2 over 2, which is equal to 1. My q is equal to my equation or my quadratic function here, x plus 2, and I just go ahead and plug in my my known x value now, the one I just discovered. So -9, and it feels like in the previous one I think it was -1 and -9, so we've had something similar to that. So now I have 3 points, but if I want more accuracy, I can then find my y-intercept. which is never hard to find. So remember, x is 0 at every y-intercept. Let me just move this down a little bit. Again, I can't use the eraser. I erased the whole screen, so I don't want to do that. So that's going to be now 0 minus 4 and 0 plus 2, which is then negative 4 times positive 2, which is negative 8. All right, so that would be 0 and negative 8. Now, that is 4 points. You don't solve for this point of reflection. I'll explain that when I draw the picture. All right, so I've got all that information written down. I can now I get some more room here. So now we can actually just sketch this. So let's write down my points just so I remember them, everybody. So I've got x-intercept is 4 and 0. The other x-intercept is negative 2 and 0. My vertex was 1 and negative 9. My y-intercept was 0 and negative 8. All right. So kind of a messy drawing, but that's what a sketch is. So 1, 2, 3, 4. 1, 2 is all I need. Now my negatives to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I didn't need to. This is where my vertex is. 1. Oh gosh, 1 and negative 9 over here. Disregard that. Right there. My y-intercept is 0, negative 8, which is right here. Remember our line of symmetry. It comes right down. So we can find the point of reflection of this guy. So if we pretend it's a mirror, there'll be another point the same distance from the axis of symmetry along that same horizontal line. So 1 unit away from that line would be right here, and that'd be my point of reflection. And again, that just kind of helps give me a bit more shape to my sketch. So I really recommend the 5 points, because really you're only solving for 4, and then you can find the 5th one on the graph, and it just gives you a little bit more shape to it. Yeah, and that is how you sketch. So hopefully that isn't too bad as well. Let's do one more quick one. Okay, so we need x and it's, oh, sorry, I gotta put this in factor form first. You'll need your factoring skills. There's also a partial, and I might do another little video on that. Um, to always pause the video as you realized. So I'm gonna call it. All right. Now I can factor this down. Factors of 10 that add to negative 7. Negative 5, positive 10, say negative 2. So that's my factor form. So now that I have that, now I can find my x-intercept really easily. I could also have just left it in standard form and solve for them. I think this is quicker. That's why I'm going to do it this way. So I'm going to have 5 and 0 as one x-intercept. The other one will be positive 2 and 0. All right, the third thing to find, we said we'll find our vertex. So P is equal to R plus S divided by 2. That never changes. So 5 plus 2 divided by 2. 7 divided by 2, so 3.5. So again, not a perfect number, but that happens. The Q value is when I take my given equation here and I plug in the x I just found, or given function, whatever you want to call it. 3.5 minus 5, 3.5 minus 2. Okay, that's 3, negative 1.5, positive 1.5. And so that'll work out to negative 6.75. So my vertex is 3.5 and negative 6.75. So those are tougher numbers. When I go to sketch, remember sketch isn't perfect, so I'll just have to estimate those. Not a big deal. The fourth thing, my y-intercept. That's when x equals 0. So I'm just going to plug x equals 0. into, I'm going to use my factored form again. I find it's just a little bit quicker. You could use your standard form. There's nothing wrong with it. Whatever you like. So that'll be a positive 30. And then again, we can find that fifth point once we actually graph it. So my sketch, actually, again, before I do that, I like to write down my points. Now, why I like to do that is just so when I'm drawing my axes, my quadrants, I don't have to draw them equal. I can kind of skew it to show more of certain quadrants if I need more of those certain quadrants. That and 30. Right, and then we're going to find that next one. So it looks like to me I want to kind of leave it more like this. Now you can see my y-intercept is enormous. But we're just sketching, so it won't be a really big deal. 1, 2, 3, 4, 5. So there's one x-intercept. 2 is the other one. 3.5. So I know 3.5 is going to be coming down here, kind of thing, and I got to go down to negative 6 and 0.75. So 1, 2, 3, 4, 5, 6, 7. So almost at negative 7. Again, it's just a sketch, so that's okay. So there's my vertex. 0 and 30. Just for the sake of the video, I'm going to say 0 and 30 is up here. And then for my point of reflection, I have my axis symmetry that's coming straight down. And then I'm going to have this. My point of reflection is the same distance away along this horizontal line. So you can see that it is 3.5 units away from the axis symmetry. So I have to count 3.5 units the other way. So I'll put a couple more on here. So we'd have, like, that's your 0.5, 1.52, 3, 3.5. So right here. So now there'd be an equal distance away. They're both 3.5 units away from the axes of symmetry, just to kind of make sure you understand that idea. And then I can just finish that off. We should also write the points in. And why we write the points in is just to kind of sure up your drawing, because I was lazy and I only put a dot up there. And so now you know what I meant. It was 0 and 30. This is 2 and 0. This is 3.5 and negative 6.75. This one is 5 and 0. This one over here, it ends up being, what is that, 7, I guess, and 30? 1, 2, 3, 4, 5, 6, 7. Yeah, and then now I've nailed everything down. So there you go. That is how you do this. Here are your steps, people, if you need. Sorry for such a long video. Not my fault, just a lot of content, right? So if you have any questions, make sure you talk to your teachers or come find me. Have a great night, everybody.